Following the previous video that I explained the DDRD framework, which is for deploying resources in a large scale urban area, along with optimizing different parameters such as resource space configurations and base station precoders, and also the resource orientation. In this video, I am going to execute some part of this code to explain for you as an example how we are going to execute the framework step by step, that you can get more familiar with my framework and easily you can run for your desired goals. So basically, if you have any question, you can send me email to this address, and I can help you in the future if you have any questions. So this code, we imported some necessary packages such as Shiona, that is very important, specifically the class of the ray tracing. We imported them along with different scripts and functions because this framework is working with through ray tracing, and we chose Shiona ray tracer to develop this framework. So for deploying RIS, we developed some algorithms and we implemented and developed in different scripts that I imported all of the scripts, so it is showing that our framework is modular. So for working with our framework, you just need to download it and going to script main and initialize and step by step and section by section run the simulations. So as I told you in previous video, this code should be run sequentially and step by step, that you can generate your desired code. But before, you need to do the initialization of the system parameters. In this example, in this video, I chose 5G, specifically 3.5 gigahertz, and I initialized the wireless network parameters related to standards of the 5G. But now, right now, we are going to execute our framework step by step. So basically, we are going to use CPU in this framework right now as an example. And I made the flag of the use real dataset true because I have the dataset. But if you don't have, you can make it false, and manually you can input several base stations and location, and it would be deployed inside of the scene. And after that, we are reading based on the result that I have simulated before, and I extracted the outer UIs in different steps. So I made here these flags false. So I have the, if you, for the first time, if you want to simulate this framework, you need to through them step by step and extract all the simulations to extract the outer. But already I have, so I made them false to show very fast to you how our framework is working step by step. So basically, section by section, I show you some part of the code, that how it is executing. At the beginning, I run the code until a specific section, which is going to uh, first initializing the network's parameters, and after that importing the base station parameters and creating the base station parameters, and then the related scene will be deployed and read in our framework. The scene, it means that the urban environment with all the buildings that we are importing to the Shiona ray tracer, and we are deploying the base stations, related the antenna configuration and setting the frequency. And after that, we are going to next step, that is cell configuration, computing coverage map, and then extracting outdoor UIs, that already I have all of the results. So it is just reading the results, not generating. But for the first time, you need to execute all of this code, and it takes time really, and you need to do all of them. And then after that, it is the calculating the receive power that based on each radio generation, it has specifically you add the transmission power, and you can calculate the receive power for each users. And after that, I'm executing the next part, that is user association. So user association is based on the is choosing assigning each users to each base station based on the maximum power that they can receive. And the user association is based on the base station and sectors, and also to each corresponding beam that giving the maximum power. So as you can see, it is executed. The users are associated to their related base stations. Then I made the flag of plotting heat map through that we can see. Here we have the cities, and it shows that based on the user association and the power that they receive, some parts are, I can show you here better. Some part all have low coverage that we need to deploy risk over there, but it is just giving you a big picture of whole network that it can be useful. So I generated this. Also, the next part, it is generating the CDF of the RSRP for 3.5 gigahertz with DFD precoder. That it shows that almost 1.27% of the users are in the outage if we set the threshold of the outage below minus 100 dBm, and the number of the users that are in the outage, it's around 1038. And after that, based on this threshold, we are extracting the outage UEs, and then we want to clustering also the outage UEs. For the clustering, we use Birch algorithm, that is very well known algorithm, that it is good for uh, data that when we have a lot of data, we can use Birch because it's super fast, and also we can choose the hyperparameter as a way that having control on the size of each cluster, that is very important for us. And also I explained for choosing different hyperparameter of this Birch algorithm in the paper, that you can read and understand why the number of the clusters is this, or the number of the parameters we chose in these values. So I executed this, and as you can see, very fast it is the outage users are clustered. The number of clusters right now is 195. In this scattering plot, you can see the points are the users, and the cross are the centroid of each cluster. So after uh, clustering the outage users, we need to do the ray tracing, uh, and based on the generating the rays, we need to extracting the reflection locations, which are the potential places for deploying the recess. So we need to do the ray tracing for that. So here in this part, it is the ray tracing part for based on the centroid point of each cluster. Already I generated the results, but here I made the flag true to just show you that it is going to extract for each centroid base and extract different information for us, as like the power of each ray, the location of interaction of each ray with each building, and based on that, after that, we can use this data for deploying our RIS. So I execute this part. uh, so it is going to run this part, but it takes a long time, and because this video, just the goal is to show how modular we can execute each part and each section. We are not going to wait to finish the ray tracing and extracting all the locations, but as you can see, it is going to generate for us the rays and extract the related information. Because of the lack of time, I stopped the simulation here. So basically, after finishing and doing the ray tracing and extracting the related information of each ray and preparing the data that we need, we are setting and organizing all the important information that each rays are giving us for following the development of the algorithm or for deploying the resources in each places based on each cluster. So after that we are going to start our algorithm. That first the first one is the reflection based. The reflection base, as we explained, has two algorithm, that is starting from strongest ray algorithm, and second one it is all ray algorithm, that together each one uh, improving the covering the outage users, a specific percentage of them, and after that we need to do other apply other algorithms. So as a example, just I made again here the flag true, that it will be run, and you can see that after each step you need to run this part because you don't have the results, and you need to generate this part of the result and going to the next step. So first I am going to run this part. So as you can see, it is starting the strongest ray algorithm, and it's going to simulate, but here in the local computer definitely it cannot be handled, so you need a powerful computer and you need to run it on the GPU to in the reasonable time you can get the results. So here you can see that it is the number of the base stations. So each base station has the several clusters outage users are assigned to each base station. So it is going this algorithm base station by stations to simulate all of them, and after that, based on the code, I don't want to continue to running each step because up to now I think it is clear how you can execute the code. After that you need to do the optimization of the strongest ray selection algorithm, and after that you need to do some post processing and computing RSRP for outage users with risk, that how each risk for each user can be useful, and they covered their users. And after that it would be finished the strongest ray algorithms, and after that it would be the algorithm, the array algorithm will be started, and following you need to run each section. Please don't be hesitated. If you have any questions or you found any problem in our framework or code, you can contact me based on the to this address, email address, and I can answer your questions easily, because I developed the framework and it is easy to handle everything. I hope this framework will help for your research, and also you can extend it, but please don't forget to cite our paper if you are going to use our framework.